Now we start the chapter on while loops. There is actually a kind of statement, a while statement, but it is a new form of statement. It is a loop. It causes repetition. This is one of several kinds of statement that form repetition, but it's the simplest and it's where we're going to start. And it behaves a lot like common English usage. If I say something like, while your tea is too hot, add a chip of ice, you'd test your tea, and if it was too hot, you'd add a little ice. But since I said while, you'd probably test again, and if it's still too hot, you'd add ice again, and so on. As long as you tested and found it was true that your tea was too hot, you'd go back and add more ice. C# has a similar syntax. It is a while statement. It starts with the keyword while, is followed by a condition in parentheses, and it has a single statement after it. The syntax here is almost exactly the same as an if statement. If you replaced while by if, you would have a simple if statement. And in fact, it's very easy to confuse these two. But with an if statement, if the condition is true, you do the statement once and then move on. Whereas with a while statement, if the condition is true, you do it, but you come back and test again in the heading, and as long as the condition remains true when you test the heading, you do the statement again and come back to the heading and test again. As with an if statement, we will generally want to put multiple statements, and so the syntactic variation is to have a compound statement with the braces and multiple statements inside. So if we write some pseudocode here that corresponds to my example with the tea, it would be while the condition is your tea is too hot, and the thing that you do, as long as that condition is true, is add a chip of ice. We can sort of fake changing this into real C# with the following assumptions. We'll keep track of the temperature, assume it starts at 115, and assume that too hot is the temperature is greater than 112. Just so we can see what's going on in our program, we'll write out the temperature in the body here if it's too hot. In place of adding a chip of ice, we will just decrease the temperature by 1. The old temperature minus 1 is the new temperature. So let's imagine going through this. We start with a temperature of 115. It is greater than 112. So we would write the temperature 115 and then decrease the temperature to 114. Unlike the if statement, you don't just then go on to the next statement beyond the closed brace here. We go back, because it's a while statement, and we check the condition again. This time the temperature is 114, but it's still greater than 112, so that being true means we do the body again. We then write the temperature, this time 114, and go on and decrease the temperature to 113. And again, we reach the end of this statement, but it is a while statement, so we go back and test the condition again. It is 113 is still barely greater than 112, so this is saying yes, go ahead and do the body again, write the current temperature 113, and then decrease the temperature. Still, we come to the end of the single statement here. We go back because it's a while loop. At this point, the temperature is just 112. This is false, and therefore we finally do skip out of this statement and go on to the first thing that's past it, and then we write that the tea is cool enough. This last line is not part of the while statement. I put it there in the example to remind you this is a sequence. This is syntactically a single statement. No matter how you mess with it inside the statement, just like when we had various ways of dealing with complicated if statements, when you are completely done with the statement, you just go on to the next one in sequence. You'll notice that these lines are numbered. For practicing following all of this, it's good to be able to keep a table. I went through it line by line. In line 1, we set the temperature to 115. This is the column where I'm keeping the current temperature, and I'll make a comment too, often. This is the line in the actual program. As we go down the table, we are following the execution sequence. We go from line 1 to line 2, and we do our test, and then lines 3 and 4 are inside the body. And here it's important that we're keeping track of the lines, because when we reach the bottom of the body here, we don't go on textually to this line. We go back to the while heading, which was line 2. As I say down here, after we finish the last statement inside the body of the while loop, we go back and we do the loop again. We do lines 2 through 4, and then again we go back to line 2 and test, and then go through the loop again. Each time we go through the loop, we go back to the heading line, line 2, until finally the condition is false, and then we skip out of the loop, and the line after the loop was 6, where we print that the tea is cool. So it's important here that the reason we're keeping track of these line numbers is it's not just the obvious straight sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or something. We go forward to here and then we go back, and forward to here and then back, all because we're going through a while loop and we go back to its heading. The biggest trick with a while loop is to make sure that the same code, there's fixed text inside your while loop, but the idea is to make the same code typically do something different and useful each time through the loop with the same actual text. And as we saw up here, we kept on writing the temperature, but we got that to behave differently each time because we have a variable here and we can change the variable each time, and hence we're not writing the same thing or doing the same thing. And while we're at it, as we're changing the temperature, we're making sure that this condition will eventually be false, so we get out of this loop. Unlike an if statement, where you skip some parts and do other parts only once, with a while loop repeating over and over, the loop can go on forever unless you make sure that your condition eventually is false. Here's a general rubric that's useful to think when you realize you need repetition and you're just getting started and you want to think of it one step at a time and not all at once. If you're going to have repetition, at this point we're going to have a while loop, which will have a continuation condition, which will certainly involve some kind of variables, something that can change, or the loop will go on forever. And generally, whatever you're checking has to have a value already. There needs to be initialization. There may need to be initialization for things that are used inside the body too. So then we come to the heading where you test, and after the initialization, if this condition is true, then we go into the loop. You're typically going to start off with the main thing that you actually want to be doing repeatedly, some kind of code that says how to do that the first time, at least. But since you don't generally want to do exactly the same thing, it's important to make some changes, typically to the value of a variable, so that your variables are ready for the next time through the loop to do this same text, but with a different action because of different values in the variables. This is the most complicated part, seeing how to get set up for the next time through the loop. we will have a number of common patterns. This idea of decrementing a variable or possibly incrementing a variable, those are simple things to do. That will be a common pattern, but it will not be the only pattern. We'll be looking at more variations. So stop and think about this code, test yourself, set yourself up a table, or keep track of the variable I, follow through. Remember, you have a while loop, so we can repeat things here. Think what is going to happen until we get all the way through and finish this loop. Stop, and then you can go on and look at my running of this little bit, which is in this program here. So here's this little program. We can run it. 4, 6, and 8 were printed. Is that what you expected? I started at 4. The condition was true. We do the loop. We write 4 for I. Here it's saying we add 2 to I, going up to 6. We come to the end of the loop. We go back to the heading of the while statement and check the condition. Now I is 6, still less than 9. So we go into the body of the loop, write 6, increment I from 6 to 8. Come to the end of the loop. Always go back and test because it's a while loop. 8 is still less than 9. We can write an 8. Increment I to 10. Now you know that the test is going to fail, but we do need to go back, follow the actual pattern here. Coming to the end of the loop, we now go back and test because it's a while loop, but of course 10 is not less than 9, and we're done. And we printed our 4, 6, and 8. The while of C# is not quite like in English. In English, typically when you say while such and such is true, you're going to do such and such. You stop as soon as the condition that you're testing becomes false. It's a little different in C#. You test when you get to this line, the heading. If the condition is true, you go through the whole body, even if the condition becomes false in the middle. And when you get to the bottom of the body, only then do you come back and test again. You don't stop instantly just because you know that when you test this, it will be false. Here's a slightly different version. See if you can predict what's going to happen here. Follow it carefully, one step at a time. You might even want to write it down in a little table. Here, there's line numbers. You just got to keep track of the variable I. See if you can figure out what's going to happen. When you're done, you can watch me run it. It's while 2, 6, 8, 10. Was that what you expected? Here I've got it all written out for this case. Initialization in line 1, I equals 4. In line 2, it's the heading. We test I is less than 9, or that is, say 4 is less than 9 is true. Line 3 is the beginning of the body of the loop. And in this time, the first line in the loop was to increment I. 4 is what I was now, plus 2 is 6, is the new value of I, which I record here as the new value of I. The next line prints the current value of I, that's this 6. We come to the end of the loop, and we go back to line 2, the heading. I has now a value 6, still less than 9, so again we go into the loop, and again we increment I from 6, adding 2 to 8. I record that, and we're going to write out then the 8 in the next line. We go back to the heading. Still 8 is less than 9. Now the next line increments I from 8 to 10, so the new value of I is 10. This no longer satisfies our condition, but we aren't testing the condition here. We still go on and finish the body of the loop. We go on to line 4 here, which prints the current value of I, which is the 10 that we've just recorded. Only then, at the bottom of the loop, do we go back to the heading in line 2. The test fails, I is 10, 10 is not less than 9, and we're done with the loop and done with our little fragment. You should be able to generate such a table to demonstrate your understanding, particularly of loops. That's the most common thing where the order of the text is not the order of execution, and you really need to keep track of it with these repeating line numbers because you loop back to the same line over and over. Even though it does something slightly different because the value of the variables are different. Here's one to think about for yourself. I encourage you to stop and think about writing it and actually do it, say in MonoDevelop. Write a program with a while loop that'll print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. You'll think about it. When you are stuck or want to listen to me some more, start up again, let me go through with some analysis. We know that we can produce a regular sequence of numbers in a loop. The blast off does not fit the pattern, but not everything has to be in the loop. The changing the numbers here is going to come in the loop. This can come after the loop. Now, if we're going to keep putting different numbers out in a loop, we need to have a variable to store the varying value. If we think of this as being a sequence of seconds or something, we might call our variable time. And remember our general rubric for the while loop here. Initialization, while, what makes us continue looping, and what are we trying to accomplish, and make sure that the variables are set for the next time through. Some people think in a different order, but I'll do it sort of in sequential order here. We need an initialization. We're keeping track of the time. Of course, initially we print out 10. We can say that time is 10 initially. And we need a continuation condition. When do you want to keep on writing out numbers as long as the number has not gotten down past 1? And all we're doing is printing out the number. That's easy. And the preparation here is very much like with our t. The next time through, the number is just decreased, only now our variable name is time. So the last line in the body is to decrease time by 1. So here's a full program to do this little thing. We have the initialization, our while loop with the condition. I could have written this time is greater than or equal to 1, but since time is going to be an integer, it's slightly shorter to write that time is greater than 0. As we saw, we write out the time and we decrement the time, doing our main thing and then updating the variables to be ready for the next time through. Our loop continues, and when we're done with the loop, here's we have our special line that doesn't fit. It's not repeated, just comes once at the end, so it comes after the loop. As you get to more complicated situations and need to do more for yourself, I encourage you to write down or anyhow think of these general steps. I mean, you can use these exact words, keeping in mind your specific situation, and it should help you focus on the next thing to do. What variables do we need? What are you keeping track of? What needs to be initialized? How will you initialize it? Certainly, this includes any variables going to be tested in the condition, because you get to the condition right after the initialization. And of course, you need to understand the basic thing for your loop is what is the condition that will allow the loop to continue, not to terminate, but to continue. A very common error is to confuse what needs to happen once with what needs to happen over and over. Think what's happening once and what's repeating. Then you need to write the main action of the loop, and you need to write it in a way that you can modify it for the next time through the loop. And in particular, how do you do these modifications? Basically changing the variables so that you'll have the right data for the next time through the loop, so the same text does the right new thing. And you may think of this in the middle, and if you thought of it beforehand, that's good too. You may need variables in the middle of your calculations inside the loop. You need to make sure that they've been declared, and we'll have to see, do they need to be initialized? It is eminently possible for you to not make changes that will eventually stop the loop. Think actively. Will the continuation condition eventually fail? It's important to think about that. Again, thinking back to the actions that are going to be done once, and what you need to think what comes before the loop and is done once there, and what comes after the loop and is done once after all of your repetition. Then you need to place those statements in the proper position before or after the loop, not in the middle.